Hi friends, here in this video we are going to see a problem on offset knife edge follower for cam profile. So let's get started. Now the question is in front of us. Whatever is given in this question, I'll write that in the form of data. It is given a cam is to give the follower motion to a knife edge follower. So the type of follower is given. I'll just mention it in the data. Then it is given outstroke during 60 degree of cam rotation. So outstroke is denoted by theta 0. It is 60 degree. Then dwell for next 30 degree of cam rotation. Dwell is denoted by theta d1. First dwell. Next return stroke for next 60 degree of cam rotation. So return stroke is theta r. Dwell for the remaining 210 degree of cam rotation. So that is the second dwell. The stroke of the follower is 40 mm, that is the height or lift of the follower. So it is lift, also called as stroke of 40 mm. Then, and the minimum radius of the cam is 30 mm. So minimum radius is given, which is the radius of base circle. Follower moves with uniform velocity during both outstroke and return stroke. That is the type of motion given. So outstroke and return stroke both are theta O and theta R with uniform velocity. Then draw the profile of the cam when the axis of the follower is offset by 20 mm from the shaft axis. So this is a case of offset follower since the offset distance is given. So it is a case of offset knife edge follower. Now once the data has been written, we'll start with the solution part. Now into the solution part, the step number 1 is displacement diagram. For displacement diagram, since the lift or stroke is given as 40 mm, I'll draw a light vertical line, measure 40 mm over it. So this is the lift or the stroke. Then from these 2 points, I'll draw 2 horizontal lines. As outstroke is given as 60 degree, so I would be converting it into a linear distance of 6 centimeter. That is 1 centimeter will indicate 10 degree. Since it is 60 degree, I'll take it as 6 centimeter and then dividing it into 6 equal divisions. So 1 centimeter will be equal to 10 degrees for the outstroke. So the outstroke of 60 degree has been shown as a linear distance. And this is the lift, 40 mm given. Then after mentioning the outstroke, there is dwell period for 30 degree. And during dwell, we don't have to divide it into equal parts because the follower remains at the same position. So I have taken a distance which is an approximate distance for the dwell. After dwell, there is return stroke of 60 degrees. So again that will be divided into 6 equal parts and taking 60 degree as 6 centimeters, dividing the return stroke as well into 6 equal parts. After that, there is a dual of 210 degree, and that need not be shown completely, so I'm just showing it with the help of a broken section that indicates the dual for the remaining part of the cam rotation. Now since I have divided the outstroke and return stroke, I'll give the notations because notation will help us to solve the problem more easily. So here this is point 0, then it is 1, 2, 3, 4, 5 and 6 for the return stroke, and here the first dual I'll give the notation in the reverse order for simplification. This is 6, 5, 4, 3, 2, 1 and 0 in the reverse order. Now how I have divided the outstroke and return stroke in a similar manner, I need to divide this lift, which is of 40 mm, into 6 equal parts. For that I am using the procedure that since if we divide 40 by 6, we are going to get the value in the form of decimal. So when you are getting the value in decimal, it is better to divide it in such a way which I am showing here. So keep the protractor, measure an acute angle between 15 to 20 degrees. I am taking it as 20, and then draw a light line passing through it. Next, since we need to divide it into 6 equal parts, into the compass, take the distance as 1 centimeter. So I have taken the distance as 1 centimeter and marking over this angle the 6 equal divisions. So I have divided this angle into 6 equal parts. Then joining the last division to this point O, we get a line here. Then go on drawing lines parallel to this line from the respective divisions. So I have divided this line into 6 equal parts, giving the notation here. Again, this will be 1, 2, 3, 4, 5 and 6. So this is the way in which we should divide the lift if the distance we are getting, but the divisions are in the form of decimal. So we have to divide it in this way. Now for uniform velocity, I'll start the projections. That is, one will be projected upward and then one horizontally from the lift. So at the intersection I am getting 1 point. Similarly for 2. Second point. Next for third. Point 4. 5 and at last point 6. Now joining all these points in proper sequence will give me the uniform velocity, and making it dark. So this indicates the rise of the follower. After that there is dual. So during the dual period the follower will remain at its position. So just drawing a horizontal line indicating the dual. After that there is return stroke or the fall of the follower, also called as the descent. So 5 would be projected up, 5 horizontally, point 4, 3, 2 and 1. So joining these points also in the proper sequence. So this indicates the fall of the follower, also called as the return stroke, where it returns back to its original position. After that there will be dual for the remaining 210 degree. So this is the uniform velocity motion. Now just I am explaining how the follower is going to rise. Here the displacement diagram has been completed. Whatever I am showing now, this is just for the explanation part. It need not be shown onto the displacement diagram. Here there is a knife edge follower given in the problem. So at first the follower is at this location, and then it will go on rising with uniform velocity as I am showing here. Finally we'll reach to the maximum lift or height, which is 40 mm with uniform velocity during the 60 degree of cam rotation. Then it will dwell for the remaining 30 degree of cam rotation. Next, after that there is fall or return stroke, where it will fall with uniform velocity for the next 60 degree of cam rotation. And since it is returning, we can see here finally it will come back to the original position, which is point O, and at this position it will remain for the remaining 210 degree of the cam rotation. So this is the displacement diagram. Now after that, step number 2 is the cam profile. So I am going into the second step, which is the cam profile. For that, first I'll draw a horizontal line, a light horizontal line. Then drawing a light vertical line. Next, the base circle or the minimum circle radius is given. It is 30 mm. So from this center, I'll mark the distance as 30 mm and then draw a light circle which will represent the base circle, keeping this center, radius 30 mm. Now after drawing this base circle, I'll just write over here that this is the base circle. Now in this problem, they have given that there is an offset. It means that this is the axis of the cam. So the follower axis is away and that distance is given as 20 mm. And it is not given in the problem, that is either we should take 20 mm to the right or to the left. We can take it anyhow. But also we can see into the problem the type of rotation of the cam, that is also not mentioned. So I can assume the direction of cam rotation as clockwise, and when the cam rotates clockwise, we have to measure the angle in an anti-clockwise sense, because that would give us the motion as desired. I'll explain when we are completing the problem. And now I'll be taking this offset to the right by 20 mm. So from this center, measuring 20, taking the radius as 20 mm, drawing a light circle. Now this circle is called as the offset circle by taking the offset radius or the offset distance. The same offset distance I'll be projecting up to the base circle, so that will give me the contact point of the knife edge follower. So here I am getting this contact point for the knife edge follower, and that would be the reference point O for the knife edge. Next, I am going to connect this point to the center, and now this line will become the reference for measurement of the angle. If this would have been an inline follower, that is if the offset distance would not have been there, then I would have taken this line as the reference and measured the angle with respect to this line. But since there is offset distance, now I have taken this line, so with respect to this I am going to measure all the angles. So starting with the outstroke, which is 60 degree, measuring this 60-degree angle up to the base circle. Then I'll divide this 60-degree into 6 equal parts by taking 10-degree each. So here I have divided the outstroke into 6 equal parts. This step we have to remember in case of offset problems, that where these divisions are cutting the offset circle. For example, this is point 0. Here this would be 1. I am giving the notation. This is first. Next there is point second. Then it is point 3. Then point 4, 5 and 6. We have to mark these points onto the offset circle, and now I would be drawing the tangents from these points, starting with point number 1, measuring 90-degree from point 1, tangent to the offset circle, remember, because the points I have marked onto the offset circle. So this is the tangent which is passing from point number 1. I'll give the notation that this tangent belongs to point 1. Similarly for point second, and we need to draw the tangents in order. So after point number 1, it is the point number second. Tangent for the second division. Next for the third division. From the offset circle, remember we are drawing the tangents. Then point number 4. Because these notations are going to help us while solving the problem. Then point 5. And point 6. So in this way we have to draw the tangents, and this was regarding the outstroke. I am mentioning here that this is theta out. Now after that there is a dwell of 30-degree. So where I have ended here measuring the angle of 60, from this same line I'll be measuring 30-degree. That will indicate the dwell, measuring 30-degree in an anti-clockwise manner. So drawing this line only up to the offset circle of 30-degree. So now when I have measured 30-degree for the dwell, I have to just project this line only up to the offset circle, because from there itself I am going to draw the tangent. So this is the tangent for the dwell, again having the same notation, 0.6. Now after showing this dwell, there is a return stroke of 60. So measuring the angle 60 where the dwell ended in an anti-clockwise sense. And remember that angle, keep it only up to the offset circle, because if there are too many lines that will lead to lot of confusion. So only up to the offset circle. This angle indicates 60-degree for the return stroke. Now dividing this angle into 6 equal parts like I have done for the outstroke. only up to the offset circle. Now giving the notations to these points as well. After 6, this will be 0.5, then 4, next 3, then point second, then first, at last 0. So similarly, I would be drawing the tangents from these points as well. Here this was 6, starting with 0.5, then 0.4, for 0, and similarly here also I'll mark from 0 the tangent. Now once these tangents have been marked, the remaining part would be for the remaining dual period. This is theta r. Next, after reaching up till this stage, I would be using the displacement diagram, and starting with point number 1, I'll measure this vertical distance, and from the base circle on the first tangent I'll be marking this point. Next, up to point number 2, again from the base circle on the second tangent. See, the notations are helping us solve the problem. Then point 3 on the third tangent from the base circle. Similarly, point 4. From the base circle, point 5 and 6 onto the sixth tangent. Also the same distance would be marked on this tangent for the dual, point number 6. Next, for the return stroke, after 6, point number 5. From the base circle onto the fifth tangent. Next, onto the fourth, point second. Third, then second. Point 1. And finally 0, which would be ending over here onto the base circle itself, where it is cutting the base circle. Similarly over here. Now all these points need to be joined in order with the help of a smooth curve in order to get the cam profile. So I would be joining all these points light and then I'll make them dark. And this is the remaining dual period. So this is the cam profile. Axis of the offset knife edge follower. So this is the offset distance of 20 mm given in the problem for the knife edge follower. Base circle radius of 30 mm, and as we can see that when the cam starts rotating in a clockwise sense, first we are going to get the outstroke, then dwell, then return stroke, and then the remaining dwell. So I have measured the angle in the anti-clockwise sense, and with that the problem gets completed. At the end, if you all find my videos helpful, you all can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.